right, I'm going to do a walkthrough for our Recitation 5, question 2. So I'm going to start with a force diagram of the ball, just based on what we know from the problem. We have our force due to gravity acting down on the ball. We have our tension from the string acting this way, and we know that's acting with this angle here being theta, because that's what we're solving for, that tension going this way with that theta. And then we're solving for that theta. And then since we have that plane there, we also have this electric force here. So what I can do, I can break that further down. We have our force due to gravity down here and our electric force over here. But this tension, which I will draw like here, can be broken down into the y component, tension y, and the x component, tension the x direction. Then from here, remember from physics 1 that we have our sum of all forces equals 0 because we're in this equilibrium. But we can also say that the sum of all forces in the x direction is equal to 0, and the sum of all forces in the y direction is equal to 0, because those are going to be our two components. So what we can say is that our force electric acting positively plus our tension in the x direction, but that's acting in the negative x direction going to the left, that equals 0. We can also do the same thing with our y direction, where we can say our tension y plus our force due to gravity acting down, so again that's being negative, that's also going to be equal to 0. That's our sum of all forces in the x direction, sum of all forces in the y. Then I can start looking at breaking down that tension force into the x and y components. So we have our y and our x here. We know that this is our theta, right? So if we're doing this, we have our right triangle. Our sine of theta is going to be our opposite, tx, over our hypotenuse, which is just our t. So tx equals t times sine of theta. And we're going to do the same thing in the y direction. This is going to be cosine adjacent, cosine theta equals the adjacent side, which is our ty, over our hypotenuse tension. So ty is going to equal t times the cosine of theta. Now we're going to look at this force electric up here. We know that since we have this infinite plane here, we know that our electric field from that plane is going to be that equation sigma over 2 epsilon naught that we had in class the other day. And we're given that our sigma, our charge per unit length, is down here, the 30 times 10 to the negative 6, charge per, sorry, not unit length, unit area, charge per unit area, meter squared is area, right? So our sigma, that's going to be our 30 times 10 to the negative 6, and then that's charge per unit area. So again, that's what our sigma is, and then we're going to 2 times that epsilon, and that epsilon is just 8.85 times 10 to the negative 12. And there's units on that, and that's going to cause this to be what we want it to. So we go ahead and solve through for that. That's going to give us 1.6949 times 10 to the 6th, approximately. I don't like rounding. But this is just the field. We're looking for this force electric, right? So to get from the field to the force, we have our force is KE times Q over R squared. That's our Coulomb's law. And then our electric field is KEQ over R squared. We multiply both of these by Q. This is going to be our E times Q equals KEQ times Q over R squared. This is our Coulomb's law. So that's going to be our force. We multiply our field times our charge. It's going to give us our force. So here's our field, 1.6949 times 10 to the 6th. We're going to multiply that by the charge of this ball that was given in the problem, 9 times 10 to the negative 10th. 9 times 10 to the negative 10 coulombs. Obviously, we're all still in the base units. And that's going to give us our electric force of 1.525 times 10 to the negative 3. Now finally, we're just going to look at this force due to gravity, and And obviously we know that force due to gravity is just m times g. And we're given the mass in the problem, but this is in grams, and we're doing everything in our base units. So we're just going to do our 0.25 grams is equal to 2.5 times 10 to the negative fourth kilograms. Just get into that again, just into these base units so that all the conversions still work. So that's going to be 2.5 times 10 to the negative fourth mass times our gravity, 9.81, and that's going to give us our force due to gravity, and that's going to be 2.4525, running into this other side, and that's times 10 to the negative 3. So this is our force due to gravity, that's our force electric. We have equations for our tension in the x and y direction, so now we can come back to this system of equations. So since this is negative and this is positive, I'm just going to move this to this side. I'm just going to add this to both sides. So we're going to get our force electric is equal to our tension in the x direction. And then the same thing over here. I'm going to move the force due to gravity to this side. So we get our tension in the y direction is equal to our force due to gravity. Now we can start plugging in what we found before. Our electric force is 1.525 times 10 to the negative 3. That's very bad handwriting. But that's going to be equal to our Tx that we set up here. There's our T times sine of theta. And we're going to do the same thing over here. Our Ty is T times cosine of theta. And that's equal to the mg that we solved for up here, which is 2.4525 times 10 to the negative 3. Now we have a system of two equations and two unknowns. Our two unknowns are theta and T, this tension, theta and our tension. Two equations, two unknowns, so we're just going to solve the system of simultaneous equations. So I'm going to start on this side and just divide both sides by cosine. So I'm going to get T, and then we divide by cosine, so that's just going to be times 1 equals 2.4525 times 10 to the negative 3 over cosine of theta. And now I have this expression for T. I'm going to plug that into this equation over here. So we're going to get 1.525 times 10 to the negative 3 equals 2.4525 times 10 to the negative 3 all over cosine of theta times sine of theta. So that's this substituted in for T over here. So I just rewrote this side of the equation and moved the divided by cosine over here, because then we can see that sine theta over cosine theta, that's just going to be our tan theta. So we have 1 theta and just some values over here. So we divide both sides by this 2.4525 times 10 to the negative 3. We're going to get 1.525 times 10 to the negative 3 over 2.4525 times 10 to the negative 3 is that's going to be equal, we're dividing both sides, to the tangent of theta. So just dividing through here, I got 0.62199 equals the tangent of theta, and then you just take the inverse tangent of both sides so that we get theta equals inverse tangent of 0.62199. And then for this, I just plugged it to the calculator, and I got theta equals approximately 31.88. So this 31.88, if we look up here, it rounds to our 32 degrees. All right, I hope this little walkthrough kind of helped. Let me know if you have any more questions, or if you want any other of the problems for the recitation or for any of the homeworks worked out as well.